Hey folks, welcome back. In this video we're going to look at capacitors and AC circuits, so let's get started. Now we've already seen capacitors and RC circuits, but now we're going to look at capacitors and AC circuits. Remember AC stands for alternating current, and we'll talk a wee bit more about what this means for this kind of circuit later on. First of all though, it says to consider the circuit below containing a resistor and a variable AC supply, i.e. a signal generator. So here we've got our signal generator, our AC supply, we've got an ammeter in series with a 10 kilo ohm resistor. And then we've got a voltmeter in parallel with the resistor to get the voltage across it. When you set up an AC circuit like this, you need to make sure that the ammeter and voltmeter are both set to measure AC current and voltage rather than DC current and voltage. It then says that the signal generator is set to a low frequency and the potential difference across the resistor to a known voltage. The current in the circuit is then measured using the ammeter, so we'll get values of current here. The frequency of the signal generator is altered, but the potential difference kept constant and the current measured each time. So all you would do is adjust the dial in the signal generator to change the frequency of the supply, and at different values of frequency you would write down the current value. If you then plot a graph of current versus frequency, this is what you would see. You would see that the current should stay roughly the same as you increase the frequency. So this shows that the current in the resistor remains constant with frequency. And we say that resistors are unaffected by the frequency of the supply and behave the same in both DC and AC circuits. If however we replace the resistor in the circuit with a capacitor and repeat the experiment, we actually find different results. And I'm just going to show you a quick simulation to help you understand what's happening in the AC circuit when we've got a capacitor. So have a look at this little simulation on the right here where we've got a capacitor connected to a switch with some wires and a signal generator, similar to what we've just seen in the notes. If I close the switch here, you'll notice that the black dots are representing the electrons flowing onto and off of the plates, and these are also flowing through the wires. You'll also notice that the plates are charging up on one side and then discharging and then charging up on the other side and then discharging. And remember, we've got an AC supply, which is the signal generator, so this means we have this continual charging and discharging of the opposite plates. Going back to the notes, if we were to repeat that experiment from before where we increase the frequency values and note down the current values for the capacitor this time, we would actually get a graph like shown here. With current against frequency, we would get a straight line roughly through the origin. And this shows that in an AC circuit, the current in a capacitor is directly proportional to the frequency of the supply. That is, in symbol form, we can say I is directly proportional to F. That's all for this video, folks. I hope you found it useful. If you did, give it a like, subscribe to the channel, and I'll see you in the next one. Take care.